So question 5, and we've got 7 marks for a minimum spanning tree here. Let me just move the page up a bit. We've basically got some story going on here, but let's go down and see part A here. It says a minimal spanning tree is used. Show clearly on the network the minimum spanning tree solution. So here it is. And let me just run you through how I would have gone about doing this. So I would have probably started over at E, and the smallest edge to add in would be the 10 to K. Once we get to K, then the smallest edge to add in 23, 34, 21, 22, 32 is the 21 up to L. When we get to L, we've sort of figured out there's big numbers over here, so the 8 is very attractive to G. When we get to G, we look around and we've got a 28, a 33, a 16, or there's a 13 back up here. So next we join the L to the F, and then the next smallest number is going to be the 15 down to A. At that point, we come back to G, and now we've basically got to head down to the bottom half of the diagram using the 28 here. Once we get to J, there's a couple of 12s, so we take the 12 down to D, back up to J, take the 12 down to I here, I think that is. Once we get there, we go back to J and take the 18 across to H, and then the 18 down to B, and then to finish off from I down to C would be the 19. And that would give us the minimum spanning tree. And then we get a couple of marks for determining the minimum cost. The reason there are 2 is earlier on we've highlighted up here that it's in hundreds of dollars. So we don't forget that once we have added up all of the edges that we just highlighted, that we remember to multiply by 100. So again, we've got some fairly daunting arithmetic to go through here to make sure, but there's always things we can do. Look for numbers that pair up and make our adding, like 28 and 12 add up to give 40, cross them off. 12 and 18 add up to 40, cross them off. 19 and 21 add up to 40, cross them off, and kind of work your way through to getting your 174, and then multiply by the 100, the minimum cost 17,400. Then I think we carry on over the page, part B. Now they've told us that edge GJ is not feasible. How will this change our answer to part A? So here's a little copy of what we did in part A, and they're telling us that the edge from G to J, the 28, is not possible. How will that change our solution? So obviously we can't use the 28, but if you remember, we'd got this top half, sort of the 1, 2, 3, 4, 5 edges done before we came down here. And across the middle here, there's a band of large numbers. So because we can't use the 28, we've either got to use the 34, the 32, or the 30 to head south to the bottom half. And so we're going to take the edge from AB. So that means we take out the 28, but we're going to replace it with the 30, edge AB. That's going to increase things by 2, but when we multiply by 100, that's an extra $200, and we will say that we will add edge AB instead of GJ, which will increase the cost by $200.